Okay, this is section 6.1, the basics of working with sets. So uh, these are the learning objectives. Now, normally what you will have at the beginning of every section is the skill prep section, but since this is the first section, I did not include that. So we're going to jump immediately into our learning objectives. This is what we will learn. Define sets and use different methods to represent them. Identify when sets are equivalent. Actually, equal and equivalent. That's what that should say. And then study cardinality for finite and infinite sets. So we have a bunch of definitions. So let's go over these. It's not as bad as you think. So a set is a collection of objects. So if we were in a classroom, I would say that all of us in the classroom are a collection of objects. So we would make up a set. A set is well defined if within that set or the collection of objects, we can identify a subset or another set within that larger set. So for example, uh, the example that I use in class is uh, hair color or ethnicity or gender or those who wear glasses or eye color, something like that. But we would have to pick whatever we want to identify, we would have to pick from within that set of objects in the classroom. Okay. Each object in a set is called an element or a member. So again, if we're talking about all the students in the classroom, we would each be a member. We could also be called an element of the set. Now, these next three definitions are the different ways that you can represent, you can write out what the set is. So the roster method designates a set in which the elements are listed between braces with commas between them. The order in which we list the elements is not important. Often we will name the sets using a capital letter. So in this case, if I wanted to list the set of the names of my dogs, Roscoe, Lola, Bo, and Nacho, I would just identify the set as D for dog. And then, excuse me, notice how for the roster method, we're going to list all of those names, all of my dog's names. I'm going to put them in a set of braces. Now, please be careful. These are braces, what you see here. This would be a set of parentheses. Okay. And then, so parentheses. And then these, whoops, these would be a set of brackets. So there is a difference between the braces, the parentheses, and the brackets. Okay. We will always represent sets by using the braces. The descriptive method does just that. It describes in a short statement what you see. So the example is the set C contains 11, 17, 19, 23, 29, and 31. Well, in this case, we're saying that C represents our counting numbers. Okay, so C, actually, we didn't even identify that. We didn't have to. Because within the set of counting numbers, if you look at this, these are also six consecutive, so one right after another. These are prime numbers. So we honed in. So the larger set would be counting numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9. Just how you learn to count. It started by 1 and you just went all the way up. Well, we can pull a set within those set of counting numbers, and this is what the example that I chose. C is a set of six consecutive prime numbers that begin with 11 and end with 31. So I was very specific about the types of numbers that I chose and where they started and where they ended. Okay. Set builder notation. This is the one that confuses some people because of the notation. So it uses variables, braces, and a vertical bar that's read such that. So if we have this example, the set of numbers 1, 2, 3, 4, 5, 6, these are your counting numbers. Okay, so we're going to say that X, the set of all X, that's what this means. The set of all X, then here's the bar, such that, so the set of all X, such that, and then we're going to specify what it is we're looking at. X is an element of the natural numbers, which are your counting numbers, the natural numbers, and X is less than 7. So that has to be 1, 2, 3, 4, 5, and 6. You cannot include 7 because this does not have an equal to. So once again, the way you read this is the set of all X in the bar such that, and then we describe it. X is an element of the natural numbers and X is less than 7. Okay? All right. So here we go for our example. Example 1. Election laws specify who's allowed to vote in an election. Consider the following group of people from Springfield: Homer, Marge, Edna, Bart, Ned, Apu, Mr. Burns, and Mo. All are allowed to vote except for the following. Mr. Burns is not a registered voter. Apu is a foreign national in the States on a work visa. And Bart is only 10 years old. So the first example, they want us to list the citizens that are eligible to vote. So I've already cheated. I've already typed this up, so I'm just going to unhide everything. So here, all they want is the list of citizens that are eligible to vote, and that's it. So again, notice that my list does not include Mr. Burns, it does not include Apu, and it does not include Bart, but we have everybody else from our set right here that's in there. We just don't have, again, Bart, Apu, and Mr. Burns, but everybody else is listed. Now, Part B says use the roster method to list the citizens who are registered to vote. So the way we use the roster method is I'm going to use V to represent the voters, and then I just list these people in the set of braces. And that's all you do. That's all that the roster method is. Okay? Now, this part, it says, who are the Simpson characters whose names begin with a letter that comes before M? Is this set well defined? Why or why not? Okay, well, the Simpsons, the characters whose names begin with a letter that comes before M, it's only Homer, Edna, Bart, and Apu. Now, I also made a comment down here that notes that we cannot include Mr. Burns because we were not given his first name. If we were given his first name, then I would know whether or not I could include him or not. Now, is this a well-defined set? And it is, oops, there should be yes right here. Yes, this is a well-defined set because it is not based on opinion. So if you come back up here, I think I glossed over it when I read what's a well-defined set. So a set is well-defined if for any given object we can objectively decide whether it is or is not in the set. In short, to be well-defined, the definition of what is or is not in a set has to be based on facts and not opinion. Okay, so it is a well-defined set because these people did come from our original set of people right here. Okay, now is it possible to list the set of funny characters? Why or why not? And no, it is not possible to list the set of funny characters because that would be based on opinion. Personally, I don't like The Simpsons. I tried watching it, but I don't like it. I don't think it's funny. But you might think it's funny. And so that would be based on opinion. While I think it's not, you might think it is. Okay, so anytime that you list a set as being well defined, it has to be based on facts. Okay, let's move on to our second example. So we have three sets that we're looking at: the set of counting or natural numbers, which is defined as n equals and 1, 2, 3, 4, and then we have the ellipses, which means the pattern. We've seen enough of this pattern to know what follows: 5, 6, 7, 8, 9, 10, and so on. The set of even numbers is defined as E equals and then 2, 4, 6, 8. Again, we know enough of the pattern So we can use the ellipses. We know that 10, 12, 14, 16, 18, and so on would follow. Same thing for odd numbers, okay? So when you use the ellipses, you want to make sure that you have listed a pattern before you apply it. So it has to give the reader enough information to know what's coming up. All right, so use the roster method to write the set of natural numbers less than 6. So here's where I'm going to pull my natural numbers from. It's 10. So remember, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so on and so on. It just keeps going. So when I use the roster method, remember that you're going to put that in a set of braces. Now it says that the set of natural numbers has to be less than 6, so I cannot include 6. It didn't say that I could include 6. So I have to stop just before that. So it's just 1, 2, 3, 4, 5. Okay. Now write the set of odd numbers that are greater than 4. Well, if it's odd, that means has to be greater than 4. Well, 4 is an even number, so we wouldn't be including that anyway. So we would start with 5, 7, 9, and again, that's enough to list the pattern. So then I could use the ellipses. Could not use the ellipses in example A to A because we were only listing those numbers that were less than 6. And then if I were to include 0 or my negative numbers, well then I get in. If I include 0, that's my whole numbers. If I include the negative numbers, then I have gone into integers. And that's not what they wanted. They wanted me to stay within the confines of natural numbers. Okay. All right. Now the next thing that we're going to see is in example 3, we're going to use the symbol for element, and it's a curved E. So this symbol is used to show that an object is a member or an element of the set. So part 3A says, if A is the set of the days of the week, we could write Monday is an element of A. And this would be read as, and then it's just what I said, Monday is an element of the set, and this is just going to reveal an A. Okay. All right, and then here, if we gave another example, I just randomly chose Thursday. Thursday is an element of the set A. However, note that we could have chosen any other day of the week. Okay, I could have picked something else, another day to represent, what I wanted to put in here. So it's not like they specifically told me what they would pick. They just said, give another example. Okay, and that's it. So hopefully you're okay with that. All right, now when an object is not an element of the set, we're going to use the symbol, and it's the E except with a line through it. Okay, so that means it's not an element. How can we write the following statement using proper notation? Well, for part A, we know that ice cream day is not a day of the week, so we just say ice cream day is not an element of the days of the week, and that's it. That's all you have to do. It's super easy. Okay, and then here, let me reveal the whole thing. Oops. Okay, so 11 is an even number. Well, we know that. So we just say that 11 is not an element of the set of even numbers because it's odd. Okay. Now for part C, BMWs are luxury cars. Well, I can't answer that because that is not a fact. That is an opinion. I've asked this question in class. I think it's a luxury car, but again, that's my opinion. So this is not a well-defined set, and there were students in class who said that BMWs were not luxury cars. Okay, so we cannot answer, excuse me, I cannot rewrite it using that symbol because it's not a well-defined set. Mexico is a member of the United States. Well, we know that's false. That is not a true statement. So we can say that Mexico is not an element of the United States. Okay, so it's really easy. Now use the descriptive method to describe the following sets. Now here you have a lot of leeway in what or how you can answer this. So the set B that contains 12, 14, 16, 18, 20, well, we know that those are even numbers, right? So a couple of ways that you can answer this. B is of the six, is, that should say one. Oh, sorry, is the set of the six counting numbers. Boy, I really screwed this one up. Sorry, guys. Of six counting numbers that begin with 12 and end with 20. And that was very specific, right? So B is a set of six. 1, 2, 3, 4. It's not even six, it's 5. Oh my goodness. Let me just change this. I can't believe I did this. I guess this is what I get for typing super fast. I'm trying to get the video uploaded. Okay, B is the set of 5 counting numbers that begins with 12 and end with 20. Or you could have said the set of all X given. So we're describing our, hopefully you noticed that we were describing the set builder notation, okay? Except I'm not using that notation. All I'm doing is describing it. So it's the set of all X, and then I'm going to define what X is. X is an element of the natural numbers, which it is, and I'm being very specific where that value or those values reside, and it's going to reside in between 12 and 20. So you have a couple of different ways that you could have written that, okay? Now, the next one, the set A containing -3, -2, -1, 0, 1, 2, and 3. You can pause the video and see how you do. So go ahead and pause it if you want. Okay. So this is what I said. A is a list of integers that begin with -3 and end with +3. Again, I didn't make a big deal out of it. Okay. So I want you to try example 6 on your own. Write how the following sets would be described aloud. Now notice, this is set notation. So if you have to come back up here to the top, set builder notation, here's where we talked about, and this is how you read it, okay? So use this example to see if you can write out A and B. So go ahead and pause the video in 3, 2, 1. Okay, so here we go. So K is an element of odd numbers ranging from 9 to 39 inclusive. Because we have the equal to, so we do include 9 and 39. Or you could have said that start with 9 and end with 39. You could have said that as well. Part B, S is an element of the states on the West Coast. I could have said S is an element of the West Coast states. Okay, either way. But that's it. So don't think that you have to write a whole lot, because you don't. It's really easy. Okay, cardinal numbers or cardinality. This is really, really, really simple. So cardinality, or the cardinal number of a set, is the number of elements in that set. So you just have to count how many elements are in your set. So if I take this as a quick example, and I want the cardinal number for the set S, well, you just count the number of elements that are in here. And there's Washington, Oregon, and California. So that would be 3. That would be my cardinal number for the set of S. If I look up here for the set A, my cardinal number for this set would be 1, 2, 3, 4, 5, 6, 7. It would be 7, and that's it. It's really easy. You just count the number of elements in your set. So I want you to try example 7. Try these 4 on your own and see how you do. So I'm going to pause the video in 3, 2, 1. Okay. So for example 7a, your cardinality, or the cardinal number for set A is 10. So we have 5, 10, 15, and then here's the ellipses, which give us our pattern. So it's 20, 25, 30, 35, 40. So now we're up to 8, and then we have 45 and 50, which gives us 10. Okay? All right, for part B, our cardinality number is going to be 15. It's the set of counting numbers, and x is less than 16. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's just 15 numbers. Now, this might be a little bit confusing, but again, remember, your cardinality is the number of elements in that set. So here's the set, C, and there's only one. How many elements do you see inside of this set? And there's nothing inside of that set. So that means that your cardinal number for this case is going to be 0. Okay? All right. Now, the last few examples that we have, again, are going to be just as easy as the cardinal number. So we talk about equal and equivalent sets. So it's two sets, A and B, are equal, and we write it A equals B, if they have the exact same elements. Okay? Two sets are equivalent, and then we use this notation for approximately equal. That's your approximation notation. They are equivalent if they have the same number of elements. So they're equal if they have the same elements. They're equivalent if they have the same number of elements, or if their cardinality is the same. Let me put this in parentheses. Same cardinal number. Let me do that, and then let me go ahead and highlight all of this. So I think that might help you out. Okay. All right. So when we look at at 8A, so we have set A is Mars, Venus, Saturn, Uranus. Set B is Saturn, Mars, Uranus, Venus. So remember, the order doesn't matter. So do they have the same elements? They both have Saturn, they both have Mars, they both have Uranus, they both have Venus. So they do. So they have the exact same elements, which means they are equal. Now, are they equivalent, which means do they have the same cardinal number? This has 4 elements. Set B has 4 elements. So in this case, they are both equal and equivalent. Okay? See how this goes? I hope it's making sense. All right, so example 8B. Well, we can look and tell that both sets do not have the same planets. So they don't have the same elements, so they are not equal, but are they equivalent? And then we can count 1, 2, 3, 4, 1, 2, 3, 4. Yes, so they are equivalent. They're just not equal. Okay. Now the same thing for C. Whoops. The same thing for C. They do not have the same elements, but they do have 4 elements in each set, so they are equivalent only. And then D. Oops. They are equal and equivalent. Huh. Somehow this accidentally got left off. Oh, there it is. I'm just kidding. I didn't know. Okay. So they are equivalent and okay. And this one, hopefully you got this one. This one's neither. This is one number, 213, and these are the numbers 2, 1, and 3. So not the same. They do not have the same elements, and their cardinal number is different. This cardinal number is 1. This cardinal number is 3. And that's it. So I hope everything, you got everything. If not, let me know, and I will shoot me a message, and then I will answer your question. All right, guys, y'all have a good day.